Hi everyone, Assalamualaikum. In this video, we will continue with Chapter 5, Applications of Definite Integrals. Alright, we look at the formula for area and volume of revolution. To find the area using definite integral, we can integrate line with respect to x or with respect to y. Right? And to find the volume of revolution using definite integral, we can integrate area with respect to x or with respect to y. Okay, depends on the axis of rotation. Alright. Area and volume always positive value. Under volume of revolution, we have three topics. Okay. The first one is volume by disc. Okay. The second one is volume by washer. And the third one is volume by cylindrical shell. Okay. We use volume by disc to find the volume of the solid object. Okay. And we use volume by washer to find the volume of the hollow object. Okay. And then we use volume by cylindrical shell to find the solid object and the hollow object. Alright. In the previous video, we discussed the first topic under application of definite integrals, which is area between curves. Now we continue with the second topic, which is volume by disc. Alright. In this section, we will start looking at the volume of a solid of revolution. We should first define just what a solid of revolution is. To get a solid of revolution, we start out with a function y equals to fx on an interval a, b. We then rotate this curve about the given axis to get the surface of the solid of revolution. Right? This is the given curve. Okay? This is axis of rotation. Okay? This is rotation sign. Okay? And then this is the shaded region. Right? So from this diagram, there is no gap between the shaded region here and the axis of rotation. Okay? So after rotation, we will get this diagram, okay, which is solid object, alright? Because there is no gap here, alright? Alright, this is the diagram before rotation. And this is the diagram after rotation at this line, right? Which is called axis of rotation. Alright, this line is called axis of rotation and this is horizontal line. So, the equation of the horizontal line is line y equals to k. Right? And this is curve y equals to fx. And the distance between the curve and the axis of rotation is called radius. Alright? Alright, so the formula for radius equals to, since the radius is the distance, okay, between the curve and the axis of rotation, the word distance here means we can put modulus sign here. Okay, radius equals to modulus curve or line minus axis of rotation. Alright. Then we can set up volume by this formula. Okay. Alright, if we have axis of rotation is a horizontal line or x-axis or parallel to x-axis, okay. So, we can write volume by this equals to pi and then integration from x equals to a to x equals to b radius squared dx, okay. And since here is dx, okay, so we need to use limit, lower limit and upper limit on x-axis. Alright? And the radius, we need to write in terms of variable x. Okay, means all mass in terms of variable x if axis of rotation parallel to x-axis or horizontal line. Right? And to get the function in terms of variable x, so we need to write y as a subject. Alright? And then we need to write the axis of rotation in terms of equation of line. Okay? The x-axis is called line y equals to 0, not x equals to 0. Okay? And y-axis, we can write line x equals to 0. Right? Not y equals to 0. Okay? Right, so this is the formula for volume by this. Okay? Volume equals to integration of area. Okay? And if there is no integration sign here, we will get pi radius squared. And pi radius squared is area of circle. Why we integrate area of circle? Okay, because when we slice this object, we slice one by one. Okay, the cross section of the one slice actually is a circle. Okay, that's why we use volume by this equals to integration of area of circle. Okay, which is pi radius squared. Pi here means constant, so we can move out from integration sign. But we cannot move out radius because radius must in terms of variable x. If the x-axis of rotation is parallel to x-axis. Alright? Alright, now we consider this diagram. Okay? Alright, this diagram shows that the shaded region is revolved about this line. Okay? This is vertical line. Alright? Alright, and then there is no gap between the shaded region and the axis of rotation here. Okay? So after rotation, we will get this diagram. Okay? And this is solid object. Alright? Because there is no gap between the shaded region and the axis of rotation here. Alright? This is the diagram before rotation. And this is the diagram after rotation. Alright? This is axis of rotation, and the axis of rotation for vertical line is line x equals to k. Alright? And then this curve we can write x equals to fy. Okay, x as a subject. Okay? And then the distance between curve and the axis of rotation is radius. Alright? And the radius equals to curve minus axis of rotation. Since the radius is the distance here, so we can write in modulus sign. Alright? Then we can set up formula volume by this when the axis of rotation is vertical line. Okay? So this is the formula when the axis of rotation is vertical line or y-axis or parallel to y-axis. Okay? So we can write volume by this equals to pi integration from y equals to c to y equals to d, and then radius squared, and then dy. Okay? Alright. If we have axis of rotation is a vertical line or parallel to y-axis, so we need to integrate with respect to y. And if we integrate with respect to y, we need to use lower and upper limit on y-axis. Okay? And we need to write radius in variable y. And to write radius in terms of variable y, we need to write x as a subject, right? So this is volume by this formula when the axis of rotation is a vertical line. So we integrate with respect to y, right? And x-axis means line y equals to 0. Okay? Y-axis, vertical line, means line x equals to 0. Right? Alright, now we look at example 1. The figure below shows the region R bounded by the curve y squared equals to 2x, y equals to 2, and x equals to 8. Using this method, find the volume of the solid generated when region R is revolved about the line x equals to 8. Alright? Alright. Now, this diagram is revolved about the line x equals to 8 here. Okay? This is rotation symbol. Alright? This is the axis of rotation. Alright. From here, since there is no gap between the shaded region here and the axis of rotation, so we will get this diagram, which is solid object. Alright. This is the diagram after rotation. Okay. And the vertical line here is axis of rotation. Okay, line x equals to 8. Okay, this is the given curve. Okay, and the distance between curve and axis of rotation is called radius. Okay, and from here, our axis of rotation is vertical line. Means that we need to integrate with respect to y. So to integrate with respect to y, we need to write x as a subject because we want variable y. So from here, when we write x as a subject, we will get x equals to y squared over 2. So we get this. Okay, we write here. Okay. And notice that we have equation with x as a subject, okay, so that we can subtract later, right? And then from here, radius equals to the distance between curve and axis of rotation. Okay, we can put in modular symbol because radius is the distance, right? Okay, so from here, we have radius equals to curve or line after we write x as a subject. So we get y squared over 2. Okay, and then minus axis of rotation equals to 8. Okay, notice that we have x here and x here. So that's why we can subtract between y squared over 2 and 8 here. Alright. And after that, we can set up volume by this formula. Okay. Volume by this equals to pi integration of radius squared. Okay. And then we can check the axis of rotation. Okay. Our axis of rotation now is a vertical line. Okay. So when the axis of rotation is vertical line or parallel to y-axis, so we need to integrate with respect to y. And when we integrate with respect to y, we need to use lower limit and upper limit on y-axis. Okay. So from the coordinate given here, coordinate of y equals to 2 here for the lower limit and 4 here. Okay. Then we can write here. Okay. Our lower limit y equals to 2 and our upper limit y equals to 4. Right? Then volume by this equals to pi. Integration from 2 to 4. And then we replace radius equals to y squared over 2 minus 8 and then bracket squared dy. Alright? Alright, for this method, if the axis of rotation is vertical line or parallel to y-axis, all the term must in terms of variable y, okay, including lower and upper limit, okay, on y-axis, right? Right, from the previous slide, we get volume by this equals to pi integration from y equals to 2 to y equals to 4 radius squared dy. Okay, and we replace radius equals to y squared over 2 minus 8 bracket squared. Okay. Alright, so now we get radius in terms of variable y. Okay, then from here we need to expand and simplify. Okay, so we get volume by this equals to pi integration from 2 to 8. After we expand square here, so we get y to the power of 4, and then we expand here, we get over 4 minus, and then we expand here, okay, we get 8y squared plus 64 dy. Okay. After we get all terms in variable y, including lower and upper limit on y-axis, then we can integrate with respect to y. Okay. We integrate one by one because in between is plus and minus sign. So we still have constant pi here. And then after we integrate y to the power of 4 over 4. So we get y to the power of 5. And then over 5 here, 5 we multiply by 4. So we get over 20 here. And then minus 8, we just keep the constant in front. And then we integrate y squared using power rule. So we get y cubed over 3. And then plus, when we integrate constant, 64 with respect to y. So we get 64y. Okay. Since this is definite integral, so no plus c. But we must put square bracket with lower limit and upper limit. Okay. And after we integrate, no more integration sign, right? Alright, from here, we substitute upper limit first into variable y. Okay, and then in between minus, okay, and then we substitute lower limit 2 into variable y. Okay, then we simplify, okay. And after that, we get the answer. Volume by this equals to 424 over 15 pi units cube. Okay, for volume, we need to write cube here. Alright. Alright, we can check the answer using symbol lab. Okay. The syntax is pi and then integration sign. Okay. And then from 2 to 4, y squared over 2 minus 8 bracket squared dy. Okay. We can compare here, right? And then the final answer equals to 424 pi over 15. Okay, or in decimal 88.80235 something. Right? Alright. Note that volume always positive. Okay, if we get volume negative value, there is something wrong when we set up formula or when we integrate. Okay, and then we leave the answer in fraction and pi. Okay, that is more accurate. Okay, right? So this is the final answer. Coming up next, more examples for volume by this. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.